Hello, our lesson today is diffraction of light. Okay, first, what is the definition of diffraction of light? Diffraction of light is the observation of alternating bright and dark fringes on a screen when light is bent around a sharp obstacle or when light spreads out after it passes through small opening, slit or aperture. What does this mean? Here we have the following experiments. First we have a laser which is the source of a light. This is the slit. Okay? Just as the slit is a hole, is an opening. Okay? The condition of the slit is here, condition of diffraction. The width of a slit with the symbol is A. It must be less than 1 millimeter. So the width of the slit, the width of the slit must be less than 1 millimeter. And the light in general is monochromatic light. Monochromatic light is a light of one wavelength. Okay, so here we have the experiment, slit of width A, and we observe on the screen, this is a screen alternating bright and dark fringes. The fringes in a blue color fringes and the white fringes here are dark fringes. Okay? These fringes have the following characteristics. This is called the central bright fringe, which is at the center on the screen. Okay, around the central bright fringe we have dark fringe from up and dark fringes from down. Okay, so this is the central bright fringes, and in diffraction always the central fringe is a bright fringe. Okay, then we have first dark fringe, first bright fringe, second dark fringe, second bright fringe, third dark fringe, and third dark bright fringe. The same as below the central axis. This is called central axis. Okay. Also we have first dark fringe, first bright, second dark, second bright, and so on. The diffraction law of dark fringes. There is a law is only for a diffraction phenomenon. What is this law? This law says sine theta equal n lambda over A. Now, what is theta? What is n? What is lambda? What is A? Theta is the angle between the central axis. This is theta, and this line for the dark fringes. First dark, maybe for second dark, another line, and so on. So this is angle theta, angle between central axis and this line. We set for dark fringes only. Okay. So sine theta equal n lambda over A. Lambda, you know that is the wavelength of the light of the source. A is the width of the slit. Now what is about central axis? Maybe -1 from down and so on. +2 second dark, +3 third dark, and so on. Now here A is the width of the slit, lambda wavelength of light, theta angle between central axis and the line of dark fringe. Central axis and the line for dark fringe. This line from the slit to the dark to the center of the dark fringe. Pay attention to this note. For small angle theta in radian, sine theta will be equal to theta and tangent theta will be equal to theta. Here we have, what is a small angle? Small angle is theta, or theta is less than 0.174 radian. So theta, when the value of this angle is below 0.174 radian, maybe 0.116, 0.115. So sine theta is equal to theta. It stays the same. Sine theta equal to theta. Also tangent theta equal to theta. If we back to the law of diffraction for dark fringes, sine theta equal to theta. Because the angle is small, then instead of sine theta equal n lambda over a, we can say theta equal n lambda over a. For the first dark fringe here, we have theta 1. Theta 1 now equal, instead of n small, in order of dark, we replace it by 1 lambda over a. Theta 2 for the second dark fringe here. Theta 2, if you want to draw it from here, to here we have theta 2. From here, from this line to the central axis. And theta 3 equals 3 lambda over a, etc. Now, two important notes here. Angular widths of central bright fringe. The central bright fringe has a quantity is called angular widths. Angular widths is alpha. Look, this alpha, so the central bright fringe facing an angle at the slit is called alpha. This alpha equal theta 1 and theta 1 to theta 1. So alpha equal to theta 1. We replace theta 1 by lambda over a. So alpha equal to lambda over a. Another width is linear width of central bright fringe. This is the central bright fringe. Linear width is the width on the screen. We can measure it by using a ruler. And the symbol is L of linear width. Linear width. L. Okay. We can say tangent theta 1 equal L over 2 over D. Apply Pythagoras theorem on this triangle. Okay. The half of this width is L over 2. Tangent theta 1 equal L over 2 over D. Okay. Opposite over hypotenuse. Also, tangent theta 1 is theta 1 L over 2D. Replace theta 1 by lambda over a. Then the linear width of central bright fringe is L equal to lambda D over a. But 2 lambda over a is alpha. So we can say L equal alpha D. Okay. Since alpha is 2 lambda over a. Here, in diffraction of light, the phenomenon is called diffraction of light, while the aspect of light is wave aspect of light. Okay? Thank you. Good luck.